Did you know your Python functions can get an upgrade, a power-up, without you ever touching their original code? It sounds a bit like magic, right? We're often taught that to change what a function does, you have to open it up, dig in, and rewrite lines. That's the traditional way. But what if there was a secret technique? A way to wrap your existing functions in new abilities, like giving your favorite superhero a brand new suit with advanced tech, all without altering who they are at their core? Today, we're diving into one of Python's most elegant and powerful features, decorators. They let us transform, enhance, and supercharge our functions, making our code cleaner, more robust, and incredibly flexible. Let's unlock this superpower. Let's imagine we're running a bustling digital kitchen. Every dish our software serves needs a few extra steps, maybe a check if the ingredients are fresh, a log of who ordered what, or a quick timestamp before it goes out. If we put those steps directly into every single recipe, our cookbook gets messy fast. Every time we create a new dish, we have to copy-paste those extra steps. This leads to code duplication. And when the health inspector, or our boss, says, "Hey, we need to change how we log orders," we suddenly have to go through every single recipe and update it. That's a maintenance nightmare waiting to happen. Our code becomes rigid, hard to change, and prone to bugs. What we need is a way to say, "Hey kitchen, for every dish you prepare, also remember to do X, Y, and Z, automatically, without us having to write X, Y, and Z into every single recipe." This is the core problem decorators solve, applying common, cross-cutting concerns to multiple functions cleanly and efficiently. Def make underscore uppercase, func. Def wrapper, name. Original underscore result equals func, name. Return original underscore result dot upper. Return wrapper. Not yet a decorator, just a wrapper concept. Wrapped underscore greet equals make underscore uppercase, greet. Print, wrapped underscore greet, Alice. Output, hello, Alice. Before we get to the magic it's simple, we need to understand a foundational concept in Python: functions are first-class citizens. Think of it like this: in the real world, you can give a friend a physical letter. They can hold it, pass it to someone else, or even return it to you. Python functions work similarly. You can pass a function as an argument to another function. You can return a function from another function. You can even define a function inside another function. This ability to treat functions like any other variable is what makes decorators possible. Here's where it gets interesting. Imagine we have a simple function, like greet, that says hello. Now, we want it to say hello in all capital letters. We could modify greet directly. Or, we could create another function, let's call it make underscore uppercase, that takes our greet function as an input. Make underscore uppercase then returns a new function, a wrapper function, that calls the original greet and then converts its output to uppercase. This wrapper completely encloses the original function, adding its own logic before or after. That manual wrapping we just discussed? Python has a built-in shortcut, a piece of syntactic sugar, that makes it incredibly elegant. It's the @ symbol, @ symbol. Think of the @ symbol like a special stamp you put on an envelope. When the mail service sees that stamp, they know to perform an extra action before delivering the letter. Maybe it's a priority stamp, or a handle with care stamp. In Python, when you place a decorator underscore name directly above a function definition, you're telling Python, "Hey, take this greet function, and automatically pass it to decorator underscore name and replace greet with the new, wrapped function that decorator underscore name returns." It's literally the same as writing my underscore function equals decorator underscore name, my underscore function, but so much cleaner and more readable. This simple @ symbol transforms how we apply enhancements, making our code look more like declarations of intent rather than complex assignments. It's a game changer for organization and clarity. Now that we understand the @ syntax, let's explore some real-world superpowers that decorators bestow upon our functions. These aren't just theoretical, they're essential tools in modern Python development. Imagine you have a core function that calculates a result. Before decorators, if you wanted to log its input and output, you'd put print statements or logging calls directly inside that function. If you wanted to time how long it took, you'd add start_time and end_time variables. This clutters up your beautiful calculation logic with concerns that aren't actually part of the calculation itself. But the genius part is this: with decorators, we can separate these concerns. We can have a at log_calls decorator that handles all the logging. We can have a at timer decorator that measures execution time. We can even have an at authenticate decorator that checks user permissions before a sensitive function even runs. This keeps our core functions lean and focused on their primary job, while the decorators add functionality like a superhero's utility belt, providing the necessary gadgets when needed. It's clean, reusable, and incredibly powerful. Def timer, func. At functools.wraps, func, hashtag preserves original functions metadata. Def wrapper, args, *quargs. Start_time equals time.perf_counter. Result equals func, args, *quargs. End_time equals time.perf_counter. Run_time equals end_time, start_time. Print, f finished, func.name, r, in, run_time.4f, sex. Return result. Return wrapper. Add timer. Def long_running_task, delay. Time.sleep, delay. Return task completed. Print, long_running_task, 2. Let's put this into practice and build a simple timer decorator. This is a classic example that really highlights the elegance of the pattern. We want to measure how long any function takes to execute, without adding timer code inside that function. First, we define our timer function. This function will take another function, func, as an argument. Inside timer, we define our wrapper function. This wrapper is what actually gets executed when our decorated function is called. It captures the start time, calls the original func, captures the end time, calculates the difference, prints it, and then returns the original function's result. Notice the args, *quargs, this ensures our wrapper can accept any arguments the original function might need. Crucially, we also use functools.wraps, func. This small but mighty line copies important metadata from our original function, like its name and documentation string, to our wrapper. Without it, debugging could become a real headache. Finally, timer returns this wrapper function. Now, we can simply add a timer above any function, and it automatically gets timed. How cool is that? We've given our functions a stopwatch superpower. The timer decorator we just built is fantastic, but what if we wanted to make our decorators even more flexible? What if we wanted our @log decorator to log to a specific file, or our @retry decorator to retry an operation a custom number of times? Here's where it gets even more powerful. Decorators themselves can accept arguments. This means we can create a decorator factory, a function that takes arguments and then returns the actual decorator. This adds another layer of customization, allowing us to configure our function's superpowers with specific parameters. We've seen how functools.wraps is vital for good debugging. Beyond simple functions, decorators can also be applied to class methods, or even transform entire classes. From caching expensive computations to rate-limiting API calls, ensuring user authentication, or even handling database transactions, decorators are everywhere in robust Python applications. They're not just a neat trick, they're a fundamental pattern for building scalable, maintainable, and highly functional code. So, we've journeyed through the incredible world of Python decorators. We started by identifying the pain points of repetitive code and maintenance headaches. We then explored the foundational concept of functions as first-class citizens, understanding how one function can wrap another. The symbol, Python syntactic sugar, revealed itself as the elegant way to apply these wrappers, transforming our functions into superpowered versions without altering their core logic. We saw how this pattern is crucial for common tasks like logging, timing, and security. And we even built our own timer decorator, bringing all these concepts together. Decorators aren't just a Python trick, they're a design pattern that promotes clean, reusable, and easily extendable code. They let us add features like logging, timing, authentication, and more, all non-invasively. They give our functions superpowers, making our code more modular and a joy to maintain. And if you liked how decorators give superpowers to your functions, wait until you see how metaprogramming can rewrite the language itself in our next episode on Python's advanced features. Don't miss it!